This time we will evaluate infinite limits or functions with infinite limits at a certain number. So consider the graph of f of x. Okay. So this is the graph of f of x. So let's observe the behavior of the graph or the function values as x approaches 4. If we observe closely, we can see, or it looks like, we have a vertical asymptote at x equals 4. Okay, so to verify that, we will evaluate the limit as x approaches 4. And since we have graphed a disconnected graph from that's one is from the left of 4, the other is at the right of 4, so we will use, or we will apply, the concept of one-sided limits. So first, let's look at the left hand limit, or the limit of f as x approaches 4 from the left of 4, or as we take values of x that are less than 4. Okay, so observe that as x approaches 4 from the left, what happens to the behavior of the function? We will look at the values that are close to 4. What happens? The values of y increases, it keeps on increasing. Like it increases without bounds. See? If we trace it, did you see the behavior? It goes up. So we say that as x approaches 4 from the left of 4, the graph goes up without bounds. So we say that the left-hand limit of f of x as x approaches 4 is equal to positive infinity. Now, positive infinity is not a number. It is just a symbol to tell you that the graph of the function, or the values of f of x, increase without bounds, or the graph of the function goes up without bounds. Now, when we have a limit that is infinity, when you say limit, it's a stopping point, right? The values of the function is getting closer to that value. So since for this case, the graph of the function increases without bounds, it means that the graph does not have a limit. The limit does not exist, but we just put infinity to be specific that the behavior of the function increases without bound. To be specific of the behavior of the function. So when you put positive infinity, it means that, again, let me emphasize that when the limit of a function is positive infinity, it means that the function does not have a limit at that point, but we know that how the function behaves, that the function values increase without bounds as x approaches that point. So for this case, as x approaches 4 from the left, the function values increase without bounds, so meaning the limit does not exist, but we know that the values of the function increase infinitely. Okay, so how about the right hand limit? We take values of x that are from the right of 4 going to 4 here. So if you observe the behavior of the function, look at the graph. The graph goes down. So you say that the function values decrease without bounds. See? If you trace it. So you say as x approaches 4 from the right of 4, the graph goes down without bounds. So we say that the right-hand limit is negative infinity. Again, this is not a number. It just tells you that the function as x approaches 4 from the right does not have a limit, but the behavior says that it goes down, or the function values decrease without bounds. So when we have cases like this, when the function value increases or decreases without bounds, we have a vertical asymptote. Okay, so for this case, we conclude that the limit does not exist. We cannot say, yeah, each of the one-sided limits does not exist, but since one is positive, the other is negative, so we generalize it as the limit of f of x as x approaches 4 does not exist. And for this case, we say that x equals 4 is a vertical asymptote. So we do the same thing for x equals 8. So we evaluate the limit as x approaches 8. So we do the left-hand limit. We can see that as x approaches, what happened? As x approaches 8 from the left, what happens to the function values? Look at the behavior of the graph. It goes down. So as x approaches 8 from the left of 8, the graph goes down without bound. So the left-hand limit tells us that the graph goes down without bound, so we say that the left-hand limit is negative infinity. Again, the limit does not exist for this case. Now, for the right-hand limit, what do you observe? We do not have a graph at the right of 8. So we simply say that f does not exist for x greater than or equal to 8. So therefore, the limit of the function as x approaches 8 from the right does not exist. So to conclude this, we simply say that the limit does not exist as x approaches 8. But still, x equal to 8 is a vertical asymptote because there is one side of the graph, there is a graph on the one side of 8 that approaches infinity, positive or negative infinity. So if you look at the graph, there is another vertical asymptote candidate. It's x equals negative 4. Why? Because at this point, the graph from the left and the graph from the right are both approaching infinity. So let's observe or let's evaluate the function as x approaches negative 4. Okay, so let's do the left-hand limit first. What do we observe? The value of f of x increases without bounds, or the graph moves up infinitely when x approaches 4 from the left. So we say that as x approaches negative 4 from the left of negative 4, the graph of f goes up without bounds. So the left-hand limit of f of x as x approaches negative 4 is equal to positive infinity. On the right-hand side, we see that as x approaches negative 4 from the right, the function values also increase without bounds. So we say that as x approaches negative 4 from the right of negative 4, the graph of f goes up without bounds. Therefore, the right-hand limit is positive infinity. Okay, again, when we have infinity as our limits, we know that the limit does not exist. But for this case, since both the left-hand and the right-hand limit is infinity or positive infinity, we say that the limit does not exist, but we know that the limit of f of x as x approaches negative 4 is positive infinity. And again, we have a vertical asymptote. Okay, so what are vertical asymptotes? Or when do we have a vertical asymptote? Basically, when we say asymptote, it is the line where the graph gets closer and closer to, but the graph won't touch that line, right? So that's the intuitive meaning of a vertical asymptote. So mathematically, we define a vertical asymptote as follows. Suppose we have a function f, and if any of the following conditions holds, then we say that x equals a is a vertical asymptote. So first instance, when as x approaches a from the left, when we have the limit of f of x as x approaches a from the left is positive infinity, we have x equals a as a vertical asymptote. We also have a vertical asymptote when the function values increases without bounds when x approaches a from the right, or if x approaches a from the left and the limit is negative infinity, or if we have the values of x approaching a from the right and the limit is positive infinity. So basically, we have a vertical asymptote at the line x equals a if the function values increases or decreases without bounds. It doesn't matter whether it's just the left hand side or the right hand side. At least one of them, at least one of these conditions, if at least one of these conditions holds, then we have a vertical asymptote. Okay? Okay, so let's review what we learned this time. We learned that intuitively when we observe the graph of the function and when if we can see that the function values increase or decrease without bounds as the values of x approach, let's say a number, let's say x equals a, then we say that the limit does not exist. So in limit notation, we write it this way. As x approaches a, so the values of f increases without bounds, we say that the limit of f of x as x approaches a is equal to positive infinity. Or this could also be one-sided limits, like the limit as x approaches a from the right or the limit as x approaches a from the left is positive infinity. But if the left hand and the right hand limits are not equal, like one is positive infinity, the other is negative infinity, then we say that the limit does not exist. This was shown in our first example earlier when we evaluated the limit as x approaches 4. Also, when the values of f decreases without bounds, we write it as the limit of f of x as x approaches a equal to negative infinity. Again, we write it this way when both the left hand and the right hand limits are negative infinity. But if they're not equal, even if they are infinity, if one is positive, one the other is negative, then we say that the limit does not exist. Also, we have learned that when at least one of the one-sided limits approach infinity, at least we also learned that if at least one of the one-sided limits is infinity, negative or positive, then we have a vertical asymptote.